Hi, my name is Bob Zolo of Agilent Technologies. Today I'd like to show you this instrument called the N6705B DC Power Analyzer. The DC Power Analyzer is an interesting instrument and it's unique in the marketplace. Its mission is to increase the productivity of the R&D engineer, and it does that by combining multiple instrument functions into a single package. So for example, in this instrument you can have up to 4 DC power supplies, plus a voltmeter, ammeter, oscilloscope, data logger, and arbitrary waveform generator. All of the capability is accessed through the front panel of the instrument, although it is a programmable instrument as well over LAN, USB, and GPIB. Today I'd like to show you some of the more basic capabilities of the power supply, the voltmeter, the ammeter, and the oscilloscope. So let's get started. My DUT for today's demonstration will be this 12-volt fan. And what I'm going to do is I'm going to power it up using the power supply. So let's get started. The main screen here, you can see these 4 colored squares. Each correspond to the 4 outputs of the DC power supplies. But I only need one output since the fan only requires 12 volts, one output. So let me zoom in on channel 1, where you can see when I hit the meter button, a large display of channel 1 and a summary of the other channels. Will only be using channel 1. The first thing I need to do is I need to program channel 1 to 12 volts and about 1 amp to power up the fan. So let me begin by entering the values here. I could either turn the voltage knob to raise the voltage, or I can directly enter it using the keypad, which is what I'm going to do. So I just set it there to 12 volts. Now I move down to the current, and I'll enter 1 for current. The output is turned off right now, and the meter, of course, is showing no current flowing or no power flowing. When I turn the output on, you'll be able to get a good measurement of the fan. So when I hit the on button, you can see now the power supply is putting out 12 volts. The fan is pulling about 350 millivolts, or that's a total of about 4.2 watts. And you can see here the fan is spinning. So this shows you how the power supply powers the fan and how you can use the voltmeter and the ammeter to make a very basic measurement on the fan. The first thing I'd like to observe about this measurement is that the numbers on the current are moving around a little bit. And that's because although this is a DC fan, the current isn't exactly DC current flowing into the fan. Now, if you wanted to know what that current actually looked like, you'd need to look at it on an oscilloscope. But of course, measuring current on an oscilloscope is a little bit difficult. It requires a current probe or some kind of a transducer, and you'd have to have an oscilloscope. But with the DC power analyzer, it's all integrated into one package. So now to access the oscilloscope function, I push the scope view button, and now what you can see is the scope trace of the fan current. So what we're looking at here is current versus time on the fan, and you can actually see that it's not at all DC, but it's actually a current waveform. Now this is a live waveform, a live measurement. As I take the fan and I slow it down with my finger, you can see the waveform changes shape. As I slow down the fan rotation, the period of that waveform changes. So what I can do now with just this one instrument and one set of connections, very simply, is power up the device and get an accurate and easy, quick measurement of the power consumption or the power being drawn by this fan. If I need to make measurements, I mean this is an oscilloscope, I could just count the grid squares, but there's also a marker mode. If I hit the scope button again, I can bring up a set of markers and I can use those markers to make measurements on the waveform. This was a simple demonstration of how to use the DC power analyzer to power up a DC fan and make some measurements on current versus time using the built-in oscilloscope function.